Alright, so this is mine and Nathan's Forestry final project. Introduction. Too often water is taken for granted. Too many people...
Did I?
Yeah, you skipped it. Too many people don't realize what a struggle it is for clean water in other countries. Since we enjoy the outdoors, we thought it would be interesting to know the difference between water from a lake that is heavily used to compare it to where it is not, and see how that affects our community.
Our research question is, if water is collected from two different places that don't have the same amount of human activity, will the pH and dissolved oxygen level be the same, or will they be different?
Facts. Our hypothesis is if the area by the water is undeveloped, then it will be better quality because there will be less contamination. Therefore, the water where there is more development will have a more undesirable pH level and less dissolved oxygen.
Alright, so now I have some references. Here's our first reference. High pH levels have the opposite effect. Alkaline water is carrying too many minerals and wants to get rid of them to balance itself back to a neutral pH. This causes scale buildup with the potential to ruin faucets and shower doors. Scale buildup can also be present in water heaters and other water-using appliances, damaging their heating elements and hindering the ability to work properly. So the pH level is very important.
Reference number 2. The pH level is a numeric scale used to specify the acidity or basicity of an aqueous solution. The scale runs from 0 to 14. If it is located lower on the scale, it is more acidic. If it is located higher on the scale, it is more basic or alkaline. Processed foods and products like yogurt, fish, and cheese are typically more acidic, while vegetables like beets, bell peppers, and kale are all high alkaline.
Third reference, adequate dissolved oxygen is necessary for good water quality. As dissolved oxygen levels in water drop below about 5.0 milligrams, aquatic life is put under stress. The lower the concentration, the greater the stress. Oxygen levels that remain below 1 to 2 milligrams for a few hours can result in large fish kills.
Facts. Reference number 4. Although water molecules contain an oxygen atom, this oxygen is not what is needed by aquatic organisms living in neutral waters. A small amount of oxygen, up to about 10 molecules of oxygen per million of water, is actually dissolved in water. Oxygen enters a stream mainly from the atmosphere and in areas where groundwater discharge into streams is a large portion of stream flow from groundwater discharge. This dissolved oxygen is breathed by fish and zooplankton and is needed by them to survive. Sheesh.
Alright, so this is our data for Hauser Lake. We collected some data there. The pH level was 7 and the dissolved oxygen was 6.
And for Granite Lake, the pH level was 8 and the dissolved oxygen was 6. We got a few pics here for you. Can you see? Maybe we'll turn those in with it. Send them in. And analysis, the water with less human activity had a slightly better pH level but the same amount of dissolved oxygen. Therefore, water where there is more human activity is not that much worse quality than where the water is not as much.
Alright, so our solution. Even though there isn't that much difference between the two water samples, the pH level of the more used lake is lower. While this may not be a drastic difference, pH level is very important, and where there is even more human activity, there may be more than in this in spirit. A solution to this problem could potentially be needed. Options may include adding alkaline to the water or reducing human activity at lakes. But for right now, the effect humans are having on lakes is not very significant, so this is not something to be worried about at the present time.
Facts. Conclusion, our hypothesis was technically correct. The water was slightly better where there was less activity, but we thought there would be more of a significant difference between the two. Unless human activity takes increases drastically, this is not something we should worry about right at the moment.
Alright, so I'm Nathan Cicilla. This is Jonathon Hansis. Thank you for watching our project.